Hi there, Jay Tedeschi here. Thanks for joining me today for this look at Inventor Pro 2016's freeform modeling tools. We're going to start by converting a couple of surface patches from an existing surface to use in the freeform modeling environment. We set the grid density for those two surfaces, and we'll begin to manipulate these by merging the edges of these two surface patches, freeform surface patches, together. Now that'll create a single freeform patch. From that point forward, we're going to begin to manipulate these to allow us to create the tub for this, the cockpit of the BAC Mono. Now note that those two blue surfaces, the lumbar pad and the leg support, those were both obtained from scans of a specific customer's backside and the rear of his legs. So we are creating the tub that those pads sit in based on that surface data. So again, we'll do a conversion. We'll select these two. Again, we'll select the density. And again, we'll merge edges. So same process that we utilized the first time, we're going to utilize this time as well. So we'll join these into a single freeform patch. And from there, we will continue on with our quest to create the tub. Now here what we're going to do is subdivide to allow us to match the grid number of the adjacent surface patch. And the reason for doing that is that ultimately we're going to join these two patches together. But first we'll use match edge so that we can drive the edge of this new freeform patch along a spline which we defined by extracting from the scan data, that scan data, I hate to keep saying of the customer's backside, but that essentially is what it is. So here's the bridge command. Now what bridge allows us to do is essentially create a new joining surface patch between two existing patches. Now we'll delete this area here that goes to the center line of the scan data, and the reason for that being that we're going to use some of the symmetry tools here. So we'll go ahead and mirror the joined patch that we have right now. We'll mirror it about the center plane, and then we're going to use bridge again to join these two together. So we essentially just select the faces, or the edges, the edges of each of these patches to join together, and then the number of faces that we want to have in there. The main purpose for modeling in this manner was so that we had access to the creation of a plane of symmetry between the two. And you'll notice how advantageous that is to me as I begin to edit these. Now, essentially with these edit tools, such as soft modification, we're able to uniquely define the area based on vertices around the point or edges that I'm manipulating, and define the area of influence for each of these edits. Now, for example, if we need, as you can see, the dark blue is where the scan data extends beyond our new part. So we need to pull that out, and you'll notice that the soft modification tools allow a much wider and more elegant modification of the surface data itself than if I had to go to every single point and manipulate it. So let's continue on now. Again, in all of these, we'll turn soft modification off. We'll grab the plane. So all along that planar face, we are extending the surface out. Again, the goal is to just make sure that the tub that we are creating fits as closely as possible with the scan data for the driver, those pads that are going to be fitted to this composite tub when it's done. You probably noticed there the mirror functionality is allowing a change on one side to automatically change another. Here, for example, if we increase the lumbar support up the side for the driver's back, you'll notice it automatically adjusts on the other side as well. Again, this is because of the manner in which we built it, defining that plane of symmetry. All of these freeform tools combine to create a very, very powerful conceptual design environment. This is functionality that literally cannot be matched through any other functionality or methodology, modeling methodology in the tool. And that being said, there are very few tools on the market that can perform this type of wholesale graphic, or I'm sorry, geometry manipulation. Here we're going to use match edge again, so we'll select the top edges of our surface and then select the existing edges of the tub as it is right now. Now we have the option of using positional continuity, tangency continuity, and curvature continuity to drive the creation of this new surface. Now once that's done, we can finish the freeform, and that surface is now added as a regular Inventor surface. Um, it has freeform underpinning, so we could always go back and edit it, but it is, as far as Inventor sees it now, it is a surface that can be trimmed, edited, just like any other surface. So we'll open up some holes here for the seat belts, seat harness. Now we'll join it to the rest of the tub. Now, as you can see, it fits perfectly with the pads which were obtained through the scans of the driver. And this is powerful functionality because it allows BAC to custom create these rather expensive automobiles for each of their specific customers. With that, I want to thank you for your time. I hope this was informative, and I look forward to speaking to you all again sometime in the near future. Thanks a lot.